You are listening to the CADD podcast. This is the place where computer-aided design and drafting meets humor and practicality, with a touch of business acumen thrown in for fun. Jim and Rocco, the owners of Zentech Consultants, the premier U.S. technology consulting firm for architecture, engineering, construction, and manufacturing, discuss the fascinating world of CAD with some humor and some honesty. The CADD podcast. Hello, everybody, and welcome to another episode of the CADD podcast with Jim and Rocco from Zentech Consultants. I'm Jim, the handsome one.
Who says you're handsome?
I do. Rocco. No one else does, handsome. And it doesn't matter. Who are you anyway?
I think we should let our guests decide who's the most handsome.
Yeah, listen, we both have a face for podcasts. That's why we do it this way instead of video. But we do have a guest in the studio with us today. We have Jason Harless. Jason, am I pronouncing that right? It is Harless, right?
That's correct.
Okay, good. I didn't want to mess up your name. All right, and Jason is a CAD manager for the Cannon Corp. He's in the house today. So, Jason, thank you so much for being here today. We appreciate you joining us.
It's my pleasure.
Okay, so Jason is here today so we can talk about 3D scanning, right? So the idea today is 3D scanning, what it is and why you need it. That's our topic. So, we talk about 3D scanning, right? The different types, the different processes, the definitions that, confuse very simple-minded guys like me. And hopefully Jason's going to make it easy for all of us to understand what we're really dealing with in the 3D scanning world. So Jason, let's start with a little bit about you and your background. Why don't you tell our listeners about what you do over at Cannon and how did you get to this point in your career?
Well, where do I start with that? I do so much for Cannon, it's kind of hard to just pinpoint one thing. Being a CAD manager, you kind of wear a lot of hats.
That's for sure.
Yeah, I'm sure you guys know that really well. But yeah, I actually have three roles over at Cannon. I'm the CAD manager, I'm an IT tech guy, and I'm also a survey tech over there. So
you don't do much work at all?
No, just a little bit. Occasionally I get to take a nap during the day because I just don't have anything to do.
Yeah. And that's between like 1 a.m. and 1:30 a.m. every alternate Thursday?
Sounds about correct, yeah.
Oh, that's funny.
So right. Breathing is an option, I guess, in my job.
There you go.
But so the main part of the 3D scanning is my survey tech background. And so when I actually started at Cannon, I started off as a survey tech. And so our survey department does all of the 3D scanning, and then everybody else, because we're a multidiscipline firm, our civil engineering, energy department, I&E, all those types of guys, they use the survey as a service for 3D scanning. And so they're kind of like our internal clients. Then we work with external clients for 3D scanning too.
Okay.
And so my role at Cannon for the 3D scanning started when I started there back in 2009 as a survey tech. And I just kind of developed the 3D scanning role at Cannon over the, 13 years or so that I've been there, 14 years.
Okay. That's not a bad place to start. So that means that you're the right guy to be asking all these questions of. So excellent. That's what I like to hear. All right. So let's talk about 3D scanning. The 3D scanning, it's a big industry trend right now. And it can be used for both interior renovation or as-built work. And it can be used in the civil world, like Jason was saying, for site work and survey. And it can even be used on a smaller platform for mechanical design, right? For scanning smaller items and parts for repair or duplication. You can scan those parts into 3D digital models. So 3D scanning, it's a really broad topic with a lot of variance in what it can do and what processes and applications you need to use for any particular type of project. So I wanted to start the conversation today really by touching base on what 3D scanning is and what it's not, right? So Jason, how do you define 3D scanning? I mean, is there a single definition that fits all uses, or is it just too varied?
Well, no, simply put, 3D scanning is just a process to use a device that projects a laser onto an object to collect data called a point cloud. And so most scanners are equipped with like a camera to colorize the point cloud. And right now in the industry, the point clouds are so nice, they're using the buzzword called reality capture, because it's basically just capturing reality and putting it into the computer.
Right. Which is really nice. Yeah, I've seen you do the the photos that lay right on top of a lot of the newer scanners, where you're pulling both the photogrammetry and the point cloud data, the scan data, all at once with some of the newer scanners, which is really cool. You can get a lot done with that. So, all right, so that is actually a pretty simple definition, right? I like that. So you were just using lasers to scan for size and shape and edges, and overlaying it with some photos and some color. Sound about right?
Yeah, that's a very simple, to the point, layman terminology way to put it.
Okay, good, because I'm a very simple guy, so that's good. So, for me, I'm kind of like you, right? I'm a civil design guy by trade, and really, I still spend a lot of time here at Zentech, right, supporting the civil industry and the survey industry. And for us, the point cloud, right, as we say, has been the big game changer in terms of scanning and modeling. And everybody knows, right, in our industry at least, that you can get point cloud scan and you can use that for your 3D modeling or your sites. But I do find, honestly, that most of the people that I'm dealing with are really not sure of what the point cloud is, or how it works, or in a lot of cases what they can even really do with it. Right? It's for a lot of folks, I think it's still more of a buzzword than an actual design tool. And I am regularly having conversations with people who are asking me, does this software that you're talking about, does that work with point clouds? And I say, well, yeah, it does. And how are you using point data? And they just kind of look at me like a deer caught in the headlights. They're just like, they don't know what point cloud data is or how to use it. They just know that somebody told them that they're supposed to be able to take it because that's what the surveyors are going to start giving us in another year or so. Okay? So, Jason, then, can you explain what point cloud data is to our listeners, right? What exactly is it, and what makes it up? How's that data collected? And how do we apply, that information to a real world project?
Well, that's going to be a lot of information here. So,
have a cup of coffee. Feel free to talk at length.
So a point cloud is a collection of 3D coordinates, XYZ coordinates, in a space so close together that it defines a shape that is being scanned. So that's hence the cloud. It's a cloud of points, just like it says in the name, right? But each one of those contain that XYZ coordinate to give you the accuracy to put to create the objects. So with that said, to create a full point cloud of an object, you have to have multiple locations scanned, because the scanner is a line of sight tool. So it can only scan what it sees, or the side of an object that it sees at that one position. So you have to scan multiple locations around an object or through a site, depending on what you're scanning, an object or like a full site or whatever. You have to do multiple locations around it, and through a process called registration, it stitches them together to create a full view of whatever you're scanning.
Okay, and that makes sense, right? With a laser, right, it's a straight line shot. So obviously you're not going to get the back of an object, you'll just get the front and what edge you can see, and then you have to rotate around it to catch the other faces and the edges. Okay, that makes sense.
And it's also based on the angle that it can see down and up too, because there's a small portion of the scanner on the bottom of it that it doesn't actually collect, because of the range of the laser. And so you got to kind of think of how the angle goes down to the ground too, because if there's stuff that you need under an object, you'll have to do a scan at a lower level to grab the stuff underneath it as well.
Good safety. Actually, that I hadn't actually considered that, right? The level structure. You tend to assume when you're going in and you're scanning, you're doing a single. Yeah, I realize, it's like survey, right? You got to do back sights and different angle and turn directions and so on to get everything, from all of its different angles, right? You can't shoot a survey through a building, and you can't shoot a scan through a building.
Correct.
But yeah, it never really occurred to me that you also have to worry about your elevation plane as well. That it's not going to go down low enough in every shot. So that's an important point. Something that I'd never thought of. So cool. All right. That's actually a pretty good explanation. Anything else you want to throw onto that before we move on?
Well, you asked how you can kind of apply it to real projects as well. And so the way that you can apply it to projects is, there's so many applications for it. You could use the point cloud as a model itself. You could do clash detection with it. You can, as you mentioned earlier, you can model objects in it. You can create ground surfaces from it. I mean, it really depends on the application and what you need to use the actual point cloud for.
And that, like I said, like I said, with surfaces in particular in the civil side, right? We see a lot of people now actively using those scans, right? Because at the end of the day, like you said, it's a cloud of X, Y, and Z data, right? Which is what we've traditionally used in the survey world when we do survey point collection. It's just an automated way of collecting a lot of that information. So we're seeing a huge growth in that. So it really does have a lot of potential benefit. I think a lot of it does come into editing and manipulating the cloud and kind of parsing down that immense amount of data into something that's workable and manageable, right? That's a whole other issue. We'll talk about that, I think, a little bit later. So, Rocco, let's wake you up since you're over there napping. We'll wake you and bring you into this conversation. You're always bugging me to run training classes and services and on point clouds, right? In terms of use, right? How much interest do you see from Zentech clients around point clouds and 3D scanning? What do we see?
Well, I think there honestly isn't a huge level of immediate interest, but a lot of people, to your point, are asking about it. They're interested in learning more about it and how does the technology that we support and train and consult on, how does it all integrate with point clouds and 3D scanning? So I think there's a lot of hype around it. I mean, Jason's more in the trenches. I guess that's a little bit more of a question for him in terms of the actual level of use that's out there. But there's definitely interest. There's definitely a lot of hype around the topics.
Yeah, and like I said, I think that people are seeing that that's where we're going, and that's why I jumped at the opportunity to have Jason on here today to talk about this, right? To help answer some of those questions that people have. Like I said, we all hear it, and at the top level, it's like, well, it sounds great, but what does it really do? Which kind of brings me to my next point, right? Which is one of the things that comes up a lot in my conversations here, right? It's the accuracy of point cloud data, right? And that's always the first question I get from clients, right? They want to know, is it accurate enough so that they can trust the data, or is it more of a, close enough scan? All right, and that's particularly an issue for folks in the survey world, from what I see. I find that architects, GCs, builders, they tend to have a little bit more tolerance for the plus and minus dimension thing, and usually because I am not an expert in this, I tend to pass that off as a hardware specific concern, right? I tell them it depends on which scanner and what you're using, but with Jason, I'm going to let you give our listeners a better answer than I can usually provide. So Jason, how accurate is 3D scanning and point cloud data, right? And is it actually hardware dependent, like I tell people, or is there another step in the process that really determines the accuracy of the scan?
There's actually multiple factors that determines the accuracy in the scan, because there's always that human error that gets introduced into it as well. And since you're doing multiple locations with the scanner, not just one scan, you can't just focus on the accuracy of the equipment itself. The accuracy of the equipment itself is super accurate. So it depends on how much of the range of the point cloud you're using from the scanner, because closer to the scanner, the more accurate it is. So just like say, for example, one of our old scanners, we used to use an HDS 6000 when we first started scanning, and some of that, the specs from that machine, just to read offhand, is like 4 millimeters at a 90% scan up to 25 meters. And so that's the accuracy involved at that distance. So, I mean, you can lose like 4 millimeters at that distance.
Which is not bad.
Not bad at all. And so, but that's an old scanner too. And they've gotten better over time. Let me see if I can pull up my Faro one that I downloaded recently and give you some specs off of that, because now we use the 330X Faro scanner, and it's a little bit more accurate. than that too. Sorry, I don't have it right in front of me here. It's more of a, let's see, at 25, so at 10 meters, 90% reflection, it could have a 3 millimeter. At 25 millimeters, 25 meters, it's 3 millimeters. So the accuracy is improving as the technology improves. And we don't use the most newest technology there is because, you know, the equipment can be expensive to replace year after year. So you use what you have for as many years as you can get out of it.
Like anything else, right? You only update when you have no choice.
Pretty much. And so the accuracy of the equipment itself is super accurate. But then you start bringing in targets and cloud to cloud registrations and, you know, those types of things, and it introduces another error. You know, the difference between the two clouds and how well that they fit together. And so you have to try to bring those down, and, you know, you can get like a millimeter or two error between the two scans, and then over the whole site it can project. And so we introduce survey into it by surveying some of our targets and to help kind of correct some of that error throughout the site.
Right. So it's you're not doing one or the other. You're really seeing that doing a blend of traditional, you know, survey and you know, geolocation tools tied with the point cloud locations helps to bring that accuracy to the levels that you really want. Is that true?
It depends on the size and level of the scan site, but yes, for the most part, yes.
Cool. Good answers. All right. So I'm going to actually let's take a quick break here to hear from today's sponsor. And when we come back, I want to get into a bit more on the actual process and the costs that are related to 3D scanning. All right, so we will be back in just a few minutes, folks, with more of the Cattle Call Podcast. All right, Rocco. Today's Cattle Call Podcast is brought to us courtesy of Civil Site Design, one of the coolest new tools to hit the site engineering and development systems in the last decade. Civil Site Design is an absolutely brilliant tool. It allows you to go in and develop gradings, roadway designs, intersection designs, cul-de-sac designs, and just about anything you need to do in the civil site world. And it does it in Civil 3D, AutoCAD, and in BricsCAD. Any system that you're working in, Civil Site Design is going to make your day-to-day workflow run a whole lot easier and a whole lot faster. It's one of the most amazing tools I have seen in a very, very long time. So we are Zentech Consultants, and we are reps who sell, support, and train you on the Civil Site Design package. And we hope you guys will hit our website and see what we got. So Rocco, how do people get involved with the Civil Site Design package and find out more about it?
Yeah, you'll definitely want to hit our website. It's zentechconsultants.net. We offer a pretty wide variety of webinars and videos and a good amount of information. And we're also happy to set up a one-on-one demo for your team, talk about it some more, show you the product in action. So again, zentechconsultants.net, or give us a call, 866-824-4459.
Excellent. The Civil Site Design, one of the best packages for the site and civil world out there. All right, everybody, welcome back to the no. Wah, wah. You know what, Rocco? That was disappointing. I didn't hit the right button. All right, let me try it again. Welcome back to the, and I'm going to leave that in the podcast because it makes me laugh that I screwed that up. There we go, the Cattle Call Podcast. I hit the wrong button. I missed my mooing cow.
What were you playing there, Bruce Springsteen or something?
Hey, don't you mock the boss. I'm a Jersey boy. You know better. The boss is everything. All right. Anyway, enough of me screwing things up today. Not that anybody who listens to this podcast is at all surprised that I screw things up. So we're talking today with Jason Harless, who is the CAD manager for Cannon Corp, and we're talking about 3D scanning. And in this segment, I wanted to talk about the costs related to 3D scanning and a bit about the process of actually using some of these scanners, right? So I wanted to start off with cost. Because the fact of the matter is 3D scanning equipment has a reputation, and I think pretty deservedly so, of being crazy expensive and out of reach for most design firms and builders. So Jason, what do you see in terms of, what are the costs associated with 3D scanning, and is it as expensive to get set up for this as people think it is?
It depends on what the design firm's idea of expensive is.
Listen, the design firms out there, you know, if it's more than 4 cents, it's too expensive.
The short answer, yes, especially in the long run. But they do have some low-cost scanners nowadays, so it's not completely true anymore as much as it was probably, I would say, 5-10 years ago. As the technology increases, prices kind of go down. But you got to take into consideration too that the scanner itself isn't your only cost. So just to backtrack a little bit when I was talking about the cheaper scanners, Leica just came out with a black 360 that works with recap, and it's around $16,000, and it's one of the cheapest scanners on the market right now. But you know, with that type of scanner, you're kind of giving up some of the features and accuracy on the scanner just so you can get into the game. And you could do things like you were talking about earlier, how like architect builders and things like that can kind of give up on some of the accuracy. Well, this is that case scenario right there where you can use this scanner to do some stuff like that. But then other companies like Pharaoh's, their scanners go from anywhere from 25,000 to like, what is it, like 40,000, I think is one of their most expensive ones. And then higher grade scanners like Leica, they go from anywhere from like $60,000 to $100,000 too. So, and it also depends on the type of scanner you're buying too, whether you're buying a phase-based scanner, which is the time of flight, or the phase-based or time of flight scanners. Yeah.
Right. And we'll talk about what those are a little bit later. I have that as one of my questions. I'm going to ask you to explain that to us. But you also point out that there are other costs. I assume there's software that has to go involved. What else has to get involved in terms of cost to get set up, you know, as a 3D scanning system yourself?
Well, you're talking about targets, you know, for targeting in between the different scans, and, you know, either magnets or survey legs or something to hold those targets up while you're out in the field. So when you scan it, it holds it in place. But software is probably one of the bigger costs, I would say, that's involved with it other than the scanner, because you have your annual maintenances on the software. And then the other cost too on top of that would be calibrating your scanner, because if your scanner's not calibrated, you're going to start losing accuracy over time. No, it's something you have to actually ship it off, and it costs usually somewhere between $5,000 and $6,000.
Okay. How often do you find that has to be done?
Maybe once, twice a year.
Okay, so you're looking at, you know, another $5,000 to $10,000 a year just in maintenance of the product as well.
Yeah, and it depends on how often it gets used, because not every design firm, you know, runs their scanner ragged like that either too. So it depends on how much mileage you get on it too.
Okay, so, you know, I think that, you know, because of those costs, which are, you know, prohibitive for most people, I think that one of the ways that a lot of people are accessing this 3D scan data in the point clouds is by using contractors or specialized scanning firms, kind of like Cannon Corp. You know, companies that have already invested the time, the money, the effort into, you know, getting the equipment and setting up an effective scanning process, have all the tools they need, and they will come in and they will scan your project for a fee. And really, that actually does seem to be a lot more cost effective and a much more comfortable starting spot for a lot of companies. And I think, you know, the big thing there is that since you as a company won't have direct control over the scanning process yourself, you need to at least understand the specifics of how 3D scanning works and what to ask or direct your contractor to do, and what formats you need and what format it should be delivered in, and what accuracy and what type of scans. And I think that means that you need to at least understand some basic scanning processes from start to finish, right? Even if you may not have the specifics for every particular scanner, tool, or software that they might be using to develop your cloud data. So I know this is a really broad-based question, Jason, but you think you can kind of walk the listeners through the scanning process? You know, how does it work from beginning to end in broad terms? And what key pieces of info should they have decided on, right, before they contract with a scanning service?
And I'm probably going to hit on that first. what they want to know before they hit on the scanning service or set up a contract with the scanning service is what you need, right? So that's where we have to come in and kind of help them understand that too, because what are you going to do with the end project? Are you designing half-inch conduit through something where you need that conduit rack really tight scanned, or are you just placing a piece of equipment in a room? So those are two totally different types of projects, to where you have to understand what are you doing with your project. So once you understand that, then you can go into setting up the scan plan, which that's going to be a general idea of where you're going to set your scanner up throughout the site or around the piece of equipment that you're scanning. And then that's a key component of scanning too, is setting up that scan plan. You want to set that up before you go out in the field and initiate any work, so you understand and have a general idea. I mean, you may not follow it like location to location, but you have a general idea before you go out there. Then you go out to the site and you start your site work, which is, setting up the targets and running the scanner, doing a control survey, things like that, just to get, collect the data itself. And then depending on the type of equipment you're using, you have to either you register it on site with the equipment there, or most of the time people bring the data back to the office and do the registration, which is a process of stitching the clouds together and creating that overall nice point cloud. They're filtering it, cleaning, and then exporting the actual data. And so that leads me to another key point too, is what software are you going to be using these point clouds in? What format do you need those point clouds delivered in? Or do you want us to actually provide a modeling service and provide a model for you?
Okay. And that's really a big thing. One of the things that has been coming up more and more is the concept of, they call this scan to BIM, right? Or, scan to model, where taking it from the point cloud data, doing the survey of the existing conditions, and really just following it all the way through and providing just a fully developed, actual solid 3D model, not just the cloud itself, whether it be, the building or the site or whatever it may be, in a workable format, Revit files or Civil 3D files or whatever else you might be working in, BricsCAD BIM, etc., things like that. Is that something, by the way, do you guys do that at Cannon Corp? Do you take it all the way through final model?
Yes, we do. We do scan to BIM, just like you said. We can provide Revit models, AutoCAD models, whatever software you want it to be modeled for. We can usually take care of that for you. And just like you said, though, I don't think always modeling is a key component itself too, because the point cloud itself can be a model. Because there's software now like Navisworks that you could actually, say you're doing a piping project and you run a piping design through a pipe rack somewhere, you could actually use Navisworks to do a clash detection with the point cloud itself. So you really only need to model your tie-in points for that accurate tie-in point, and then run your design, and then use the point cloud and your design model and run a clash detection to see if you're hitting anything.
Oh, that's really nice. Actually, I did not know you could do that. That's actually really cool. That does save a lot of time and effort in modeling things just for, clash detection and connection and so on. So that's definitely beneficial. Nice. Okay, so let's bounce over to Rocco here for a minute, bring him back into the conversation, because I know he gets bored when we start talking about the technology stuff. So Rocco, we've looked here. I know you and I have looked at offering scanning services here at Zentech in the past, but we have never actually pulled that trigger. It's not something that we actually do. And so what has been the big thing that's stopping us from making that move, right? And is it the same thing that our clients are hesitating over?
Yeah, I think it's a couple of factors, right? I mean, number one, as you guys are seeing, it's complicated. It's not an easy process to get your hands around. You have to have the right folks on board, right, who know what they're doing, and it's not easy to find people within the industry nowadays, right? There's a skill shortage within the industry as a whole, let alone finding people who have a solid understanding around this technology. And then the third point is the cost. It's not cheap. So, I think those are big factors. And I mean, the final point is you you can only be good at so much. That's.
Speak for yourself. I'm good at everything.
Oh,
but I think you're actually right. It's always the catch-22 there when you're looking at this sort of thing. You don't want to invest the money until you have a big job that will pay for it, but you're not going to get a big job that'll pay for it until you've invested the time and the money to be good enough to warrant getting that job. So it's a tough thing, and that's why we have folks like Jason and Cannon Corp to do it for us. So, all right. So Jason, I said I was going to come back to this question, right? So, as I understand it, there are really two big primary types of scanners. There are phase-based and time of flight. And honestly, that's about all that I know. And I think that's probably true for most of our listeners, right? We get on the interwebs and we do some quick reading and, quickly get lost down in the tech specs and, lists of terms like, redshift and prismatic tolerances and we're just done. We move on, right? But luckily, Jason, you're here to help an old man like me understand what these things really are. So what really is the difference between a phase-based and a time-of-flight scanner? And is it really important for us to know which type of work goes best with which type of scanner?
That is a very important thing because the phase-based and time-of-flight scanner have two totally different specs. A phase-based is more of a short-range scanner that does a lot of points really fast in a short area. And a time-of-flight scanner it's a slower scan, but it covers a much longer range. So you could do like, say, what was it, like 300 meters with the phase base, but you can go up to like, I can't remember what the specs were on the time of flight one, but it's a lot larger range. So in the difference between the scans, a phase base can do a scan in like 6 minutes with photos, and a time of flight could take like 30 minutes to do a scan, or 40 minutes, depending on the resolution, of course. And so what the actual difference is for the phase-based, so the phase-based scanner is, let me see, the phase-based scanner, I got it backwards. I have it set up for the time of flight first. But what the phase-based does, it sends a constant laser out, and what it does is it measures the phase shift of the signal coming in and out, but as it reflects off of an object, and it measures that to get the distance. And the time of flight laser is a pulse laser that sends out a really quick pulse laser that actually measures the time it takes to reflect off of an object and get back to the laser. And so as you can see, it kind of takes a little bit longer to do something like that.
Okay. And so you're saying that the time of flight one then is just going to give you much more accurate results over a longer distance.
Correct.
Okay. And I got to assume then that the price for a time of flight type of scanner is going to be much higher than a phase based.
Correct. Because most companies nowadays use the shorter range scanners that they sell, and those are the cheaper ones. The time of flight ones are definitely the more expensive ones, like the Leica models.
Gotcha. Okay. All right. So that is good to know. All right. So now I would assume that generally in terms of, like you said, type of work, I'm going to assume that phase base is probably, like we said, good enough for like internal architectural building work. But if you're getting out onto a site and you're doing site work, roads, things like that, you're probably going to be looking towards a time of flight scanner. Is that correct?
Not necessarily. We use our Faro scanner to do roads. You just have to do more setups because it does have quite a range on it. 300 meters isn't something to kind of turn your nose at for a project like that. So yeah, you just go out and do multiple scans, of an area, and you collect more data than what you would get with a time of flight. A time of flight scanner is more for when you need that reach. So you're scanning a bridge and you can't get close enough to it to actually scan the full bridge.
Gotcha.
Things like that.
Okay, yeah, that makes sense, right? Because you're not going to shut down the bridge into traffic and take 12 shots along the bridge in the middle of the day. All right, so yeah, okay, I see that, because that was going to be my next question, right? Then, if you can get 300 meters, why would you need a time of flight? But that does actually make sense on really long projects that you can't easily access. That's your better feature. Okay.
Correct. Or things like, say, the pyramids and things like that, where you want a farther reach for archaeological type scans.
Have you done the pyramids?
I wish. That'd be awesome.
Get him to send you to Egypt. Tell him I need to come along and do a live podcast from here because I'd totally love to see that.
I believe they have scanned those, though.
I don't doubt.
Somebody ask him. I'll have to look it up, though, to be sure for fact.
Yeah, I know that's actually become like kind of a big thing. There's been a lot of changes in terms of the scanning for the archaeological sites. They actually do quite a lot of three-dimensional modeling and scanning of those as they're going in, so that if anything does get accidentally moved or shifted or they have a problem, things can be referred back to the original state that they were when they first got in there. So that actually I'm sure they have.
We've done a few historical buildings, adobe houses, and things like that around here in the San Luis Obispo area.
That's cool what you can do with it. The other one that I find absolutely fascinating, apparently they've been doing a lot of the police departments throughout the U.S., their forensics departments have actually, invested in scanning technology. So when they hit crime scenes, they set up like a 360 scanner. And actually, before anybody, they just scan everything so they can go in and tell where everything was, again, in case something from a forensic standpoint gets accidentally moved. So, kind of interesting. So much that you can do with this technology. It's cool.
Yeah, I think Faro has a good market on that, actually, going into the forensic stuff. That they keep Faro scanners in some of the police cars to where they could just go up and do a couple setups and do like a cloud-to-cloud registration so that they can see how the crime scene is, and they can actually use those in their animations to develop, like bullet projections or blood splatter lines and things like that.
It's just brilliant, right? Things that we tend to think of in terms of, hey, I want to build a building, or I want to know how big this room is. It can be adapted to so much more when you get people, working with it with a little bit of imagination. It's really cool. So, okay. So I know that we've been covering a lot of technical stuff here today. Again, at a high level. I know Jason can go way more technical. And before we close out, I want to give Jason a chance to do that and kind of sum up his views on 3D scanning. And if there's more technical stuff you think that we need to know. Obviously, Jason's a big fan and he thinks it's important. And I want to let him tell us why. So, all right, Jason, I'm going to give it to you then. Right? In your own words, why do you think 3D scanning is important? And where and how do you see it bringing the most benefit to our listeners?
I think one of the key important things that gets overlooked a lot is the safety aspect of using 3D scanning. So we've done a lot of oil field work over the years at Cannon. And before we'd have to send guys out with a tape measure and a wheel, and he'd have to walk through the whole site and actually climb up on equipment and measure things.
I used to have that very job, and it is not fun or safe.
It isn't. And you're getting something that's inferior as well. You're not getting a super accurate, because they're just, measuring it and saying, oh, that looks like it's about 90 degrees, and they're just guesstimating a lot of it. And so when they're climbing around all that stuff, you got falls or burns or whatever. You're just in a lot of danger doing that type of stuff, climbing around that type of equipment. And when you do a scanner, you could just scan it right from the ground or just on a catwalk or something and stay away from the more dangerous environments with the scanner itself, and you're getting a more accurate measurement than you would with that tape measure or that wheel or whatever you're measuring with. So safety, I think, is probably one of the most key things too, because if you get a surveyor out in traffic trying to do shots out in the middle of a busy road, then you can get hit by a car, but if you're safely on the sidewalk on the side of the road, unless somebody's drunk and decides to kind of veer off and take you and your scanner out, well, you're a little safer on the side of the road than standing in the middle of the road with your rod, right?
Absolutely, no doubt about that. Yeah, like I say, it's actually funny. Like I said, I actually did. I worked down in Houston for a while at a fuel oil terminal down there, doing the actual the dock inspections and so on, and also doing interior tank inspections, which is something that has gone completely now to scanning. Where we used to have to go in and we have to put on hazmat suits and have regulators and oxygen and feed masks and trade out every 2 hours, and we'd be inside these compressed tanks. Now you can go in once, set up the scanner, and leave. And it's a dramatic difference in safety levels, because let me tell you that if you've ever done that and been inside an oil tank, that is not a place you ever want to be. That's miserable. So, all right. So I think, yeah. So, all right, I think we can leave it there for today, and I want to thank Jason Harless for being here and helping us understand the underlying concepts and concerns of 3D scanning. And Jason, I hope we didn't frighten you off with our ignorance and Rocco messing up when we came back from the break. I'm sorry, folks. Rocco messes things up all the time. But we really do appreciate you being here, Jason. It was a great interview, and I hope that you'll consider coming back in the future to talk to us more about 3D scanning and some of the other tech that you're using over there at Cannon.
Yeah, I could go off on the 3D scanning, or we could actually talk about CAD management.
We can do that too. CAD management's always one of my favorite topics, so we will look forward to that, and we'll see if we can hook up another one for you in the future. All righty,
Great.
Folks, thank you all for being here, and we will catch you next time on another episode of the... Oh, look, it didn't play. Look. Oh,
you
man.
just have to move now, Jim.
Oh, Rocco, you broke it now. I can't play my moo sound. There it goes. The cat. There. Oh, now it decided to play. Here, I'll try one more time. Ready? The Cattle Call Podcast. Wow, nothing wanted to work today. All right, folks, take it easy. Catch you next time. All right, everybody. Today's Cattle Call was brought to you courtesy of Zentech Consultants. That's Rocco and I. Zentech Consultants works with design and manufacturing firms to help our clients purchase and implement the software that they need in these complex industries. We provide a single point of contact for clients to buy, develop, and learn the most vital software systems for your specific needs. Zentech strives to be your trusted technology partner from your initial needs all the way through long-term support and training for your entire staff. So Rocco, why don't you tell them how to reach out to Zentech?
All right, yeah, you can reach out to us through zentechconsultants.net. You can email us at sales@zentechconsultants.net, or you can even call us 866-824-4459.
Excellent. We look forward to hearing from you all.